So, friends, good morning. Welcome to this lecture series of geomorphology, and today we are going to discuss about the soil formation process and how the weathering is responsible for soil formation, what soil means to us and what is its important, how geomorphologically the soil becomes important from geological history. So, as you remember your last class, we are talking something about the weathering products, and among these weathering products, soil is the most important weathering product we get. Why? Because without soil, we do not have cultivation. Once cultivation is not there, the existence of life would not be there. So, soil is the most important weathering product that we have ever got. So, what does it mean? What is soil? Soil science is called pedology. Pedo means it starts from a word ped. Ped means soil structure. So, once we say soil science in geomorphological term or a scientific term, we say the study of soil science is called pedology. So, pedology and geomorphology, they are closely interlinked. How? If you remember when we are talking about this geomorphic process, there are different geomorphic process they are responsible for soil formation. Because for the soil we need some material, parent material, which is called parent material. From this parent material we weather it physically, chemically, biologically, in combination of all those weatherings, then we disintegrate the parent material and we decompose the parent material. So, organisms grow and those organisms they break down from complex mineralogical bonds to simple mineralogical bond. Then the humus is decomposed and the organic matter decomposed and the minerals gradually reduce their size by physical weathering. So, a mixture of all those things, they create a layer on this parent material, and that layer that promotes the growth of rooted plants, and those layer which promotes the growth of rooted plant, that is called soil. It is the definition by agricultural people or these people who are involved in agriculture. But for engineers, the definition is of soil is different. For the engineers, any unconsolidated broken material, any, irrespective of it is decomposed or it is allowing to grow the rooted plant, irrespective of all those things, any broken material, broken debris, the surface of earth where residual form, it may be in residual form, that is called soil. So, there are two types of definition, one definition by agriculturist, another is by engineer. But for geologist, the soil is means it has to develop some layer, it should go up to sufficient weathering, sufficient decomposition, some layers has been developed, then we can get soil. And for geologist, we only and only term those reduced material or those weathered material to soil if there is soil structure developed, soil structure, the unit soil structure, that is called ped. If pedological features, that means the soil structures until unless it is developed, for geologist that is not soil. So, there are three schools of thought, one is agriculture, one is engineers, one is geologist, and we will consider those definitions of soil which is satisfied by the geologist or for the geologist. So, for geologist, soils are characterized by horizons. What is horizons? So, now you see, suppose by any means a parent material is lying here for millions of years or thousands of years or so. So, with definition, with disintegration, with decomposition and with the eluviation and alluviation. What is eluviation and alluviation? You see, once we have a parent material layer, so raining is there, so due to raining, due to disintegration and decomposition, some materials they move along these boundaries or move across these boundaries from one place to another. That is called alluviation. So that means materials removed from the upper layer and gradually move downward, and that will be accumulate somewhere else. So by this way there are layers are developed. Similarly, if you remember our weathering class, we are talking something about the rhizosphere. Rhizosphere means it is a biologically active layer. So within the soil we have a biologically active layer. We have a layer which is characterized by leaching or removal of material, and those removal of material they will be accumulated somewhere, that will define another layer. Similarly, at the upper surface, close to the surface or the upper surface, there will be organic matter will accumulate, that will also create a layer, and below that once we moving across this boundary from top to bottom, then below we will get this fresh rock material, and above this fresh rock material the rocks will be slightly weathered or these minerals will be slightly weathered, and then will be more weathered and more weathered and more weathered. So in this way, if you see a soil profile, there are different distinct layers are developed, and those layers are called soil profiles. So or the soil horizons. So distinctive weathered zones approximately parallel to the surface of the ground that are produced by soil forming process. That is, soil forming process is key here. What is soil forming process? That we are discussing whatever this weathering is there, erosion is there, transportation is there, accumulation is there, organic decomposition is there, chemical decomposition is there, all those total package it is under soil forming process. So by this way 5 principal horizons from the surface to downward into a unaltered rocks are conveniently given capital letters, the soil horizon names. Those soil horizon names are termed as O, A, E, B and C. So O is the top which represents for the organic matter, and C is the bottom which represents the parent material. But below these 5 master horizons, there is underlying parent material such as bedrock, alluvium or other material from which the soil has formed. It is sometimes referred as R horizon. So that means we have 5 principal horizons, and below that 5 principal horizon, that is one horizon that is called R horizon, R for regolith, and it is unweathered and represents the parent material. And each sub horizons O, A, E, B, C, all horizons that again subdivided into sub horizons. So in this class we will not discuss about the sub horizons, but we should keep in mind those 5 principal horizons, and each horizon has distinct characteristics, and it represents distinct class of weathering, distinct degree of weathering, and each horizon it signifies something during the soil formation process. But it has to be kept in mind here that not necessarily all these 5 principal horizon we will get in each geological or soil profile. So it may possible that after O and A horizon there will be C horizon, there after A, E, B horizon there will be C horizon. So that means I want to say these 5 principal horizons they represent the ideal condition. If the condition satisfied, then in each and every soil profile we will get this O, A, E, B and C horizon. Otherwise there may be some horizon missing at some places. That depends upon the soil forming processes involved. So depending on the process, depending on the time and process both are related here. So depending upon the process and time, we may get all 5 principal horizon at a point, or we may not get those 5 all 5 ideal principal horizons at a places. So, in between there may be some transition horizons. For example, suppose E and B, some horizon it is not approaching to B, and it is some horizon it is not totally approaching to or fully approaching to E. So, in that case we can say EB horizon. So, similarly, once we go downward, there may be or may not be distinct horizons present. Some horizons may represent the transition from one horizon to another horizon. So, accordingly we name the soil horizons at the point of study. So, these are some field photographs of soil horizons taken from Ganga plain. In the western side, or these 4 photographs, if you see here, the scale is given, it is of 1 feet scale, and this 5 horizons has been marked. Here 5 horizons are marked, here 6 horizons are marked, and if you see here the scale, it is 1 feet. So, around 3 feet, the total thickness here is around 3 feet. Similarly, the total thickness here will be around 5 to 6 feet, but if you see here in soils from Haryana plains, these are 2 photographs from Haryana, and you see this soil thickness is this much, its soil thickness is this much or beyond that. So, that means I want to say, though we have 5 principal horizons, so thickness of those 5 principal horizon it is not same throughout. That depends upon the parent material, that depends upon the climate, that depends upon the degree of weathering, that depends upon the time under which the weathering condition is prevailing. So, depending upon all those factors, the thickness of soil horizon varies. In particular, if we confine ourselves in the Indo-Gangetic alluvium, in the western part like the western UP, Haryana, Punjab, we will get thick soil development. Similarly, if we go to eastern part like Bihar, eastern UP, so we will get very thin horizon of soil. So, that depends upon the degree of weathering, the time, the parent material, all those things. And second thing, the very important thing here I want to mention here, that it is the tectonic process which is responsible for soil formation. Soil is a tool nowadays being used successfully to define the tectonic stability of an area. The thicker the soil, the more tectonic stable the area is. So, accordingly, if we compare these 2 photographs or these 2 part of these photographs, these 4 photographs, they are representing thin soil. However, these 2 photographs represent thick soil. So, that means we can say these area or Haryana, Punjab, those area, they are tectonically relatively more stable as compared to the eastern Gangetic counterpart. And soil formation or soil development, it represents an unconformity in geological time scale. How? Unconformity, we know different type of unconformities. Here soil formation means the surface is exposed to the surface. So, exposed surface means it is above the depositional level. So, as per the definition of unconformity says, it is the surface of erosion or non-deposition in a geological time scale. So, here once we allow the sediments to expose to the surface, interact with the atmosphere, interact with the organisms. So, in that case, that means it is getting decomposed, disintegrated. So, soil formation starts. So, till that the area is not covered with younger sediments. That is why soils of an area, it represents the unconformity. Similarly, in geological past, if you analyze the geological record from Precambrian to recent, we have different soil profiles, they are covered with younger sediments. So, those are called paleosols. Paleosols means old soil. So, either soil or paleosol, that are indicator of surfacial exposure, that means weathering, erosion. So, that other words we can say that is representing the unconformity in a geological time scale. And soil plays important role to define the paleoclimates, because if you are getting a soil profile or it is a paleosol profile, it is a geological treasure in terms of defining the geological history, in terms of defining the paleoclimatic process, paleotectonic process. Okay. So, that means paleosol study is also is important in terms of geology to unravel the past geological climate. Now, let us discuss about these 5 principal horizons of the soil. The first is O horizon. O is uppermost horizon, fresh to partly decomposed organic matter. Here if you see this O or humus organic O horizon, here this is black in color and it is organic matter. That means all the organic matters they are embedded here and forming near about black color, and this is called O horizon. Below that is A horizon, mineral soil mixed with humus and dark color. Now, humus is here, this is O horizon, and here these minerals in the parent material they are mixed with humus and forming a mixture horizon of mineral and humus or organic matter. This is called O horizon, that is called topsoil. Then below is E horizon, and gradually you see how the color is changing. E horizon means zone of maximum alluviation. Alluviation means leaching, maximum alluviation or leaching of clay, iron and aluminum, leaving residual minerals such as quartz, sand, silt, size, lighter color and A horizon. Now, you see whenever we talk about parent material or alluvium is there on which the soil is getting formed, we have mixture of minerals, either ferromagnesian mineral will be there, quartzo-feldspathic mineral is there. So, if you remember our weathering class, the ferromagnesian minerals they are more prone to weathering. So, their weathering rate is fast. So, now suppose we have a mixture of all those minerals and we allow it to weather physically, chemically and biologically. So, the ferromagnesian mineral they will leach from this place. So, the resultant will be or the resulting mineral will be enriched in the quartzo-feldspathic mineral which moves around of light color. So, now here this is the maximum alluviation zone or leaching zone. Once these dark color minerals they are weathered and leached out. So, the resultant horizon will be white in color and rich in quartzo-feldspathic minerals or the light colored minerals. So, now the question arises, if it is leaching then where it will move, at which place it will accumulate, the leached material where it will accumulate. Now, come to B horizon, it is the zone of eluviation or accumulation here. So, that means those minerals which are leached from E horizon and they are accumulating at the lower horizon or just lower horizon, it is called B horizon. So, it is the accumulation of clay, iron, aluminum compound from the above with development of distinct structure. This is important where it is the development of distinct structure, that is the paired structure such as granular, blocky, prismatic, aggregates, colors more intense than overlying and underlying horizon, because leached material are placed here, accumulated here. So, that means it will change the color of this parent material. So, that is why and that is why there will be development of pairs, paired structure like blocky, prismatic, whatever these structures are there, whatever the size is there. So, that means B horizon is the actual soil horizon, it is the prominent soil horizon. Then come to C horizon, relatively unweathered, unconsolidated mineral matter below the zone of major biological activities may be mechanically fractured, stained by oxide or loosely cemented by calcium carbonate, gypsum, iron oxide and more soluble salts. And if you see here this figure, there are distinction of different colors of different horizons. Similarly, C is the parent material horizon, then R is the bedrock. That means, it is the intact rock on which this weathered material it is weathered, and this is the weathering zone, it is here clearly, and this is the zone of accumulation, and it is the zone of leaching, it is the zone of mixture of organic matter and parent material, and it is the zone of organic matter. So, these are the 5 principal horizons in a soil profile, in an ideal soil profile, but not necessarily all those 5 principal horizon will present everywhere in a soil profile we want to examine. So, that depends upon the degree of weathering in terms degree of exposure or the intense the climatic condition. If you suppose a rock is exposed in humid, warm and humid climate, that means it will undergo rapid chemical weathering. So, rapid chemical weathering may able to develop all these 5 horizons and sub horizons. However, if it is in cold climate, only maybe under R horizon there will be C horizon, there will be hardly any B horizon or E horizon or A horizon. So, that means where we are going to see it, where we are going to examine a soil profile, that will define whether we will get this all 5 principal horizon at a place or not. The horizons in a soil profile illustrate the principle that many mechanical, chemical and biological weathering process operate simultaneously near the surface, but the different rate and to various depth. This is important. The different rates and various depth, as we are discussing, that depends upon the climate. So, most geologists would observe the effect of mechanical weathering on the rock mass in the upper part of this R horizon. So, we are talking something R horizon, it is the parent material, this is unweathered bedrock on which the soil horizon is developed. So, this R horizon it is totally unweathered. So, this R horizon it may be regolith. Regolith means soil and regolith, there are two different things. Regolith means this weathered material from the parent rocks, and soil means the weathered material under in which the soil horizons has been developed or soil structures has been developed, but regolith no soil structure, only the weathered material on the parent material or in the bedrock, that is regolith. Its lower limit is not defined, and to pedologist the R horizon or the regolith unusually implies the rock mass beneath the soil profile. So, here this R horizon, if you see here, this is R horizon, that means it is totally the bedrock, and this is the regolith, and this is C horizon, and this is B, E, A, something whatever is there. These horizons are distinct from one another, and this distinction is based on the color, based on the chemical composition, based on the grain size and other diagnostic criteria is there. Soil profiles are divided into horizon and sub horizons that record the intensity and the duration of the various soil forming or weathering processes. If you see here, it is the photograph of a soil color chart, and soil color is defined by Munsen color. Here is color, it is defined by Munsell color chart. It is one page of this Munsell color chart. If you see here, this direction hue is increasing, and in this case suppose these are these soil colors. Generally these are the holes within that page. So, if you want to examine a soil color, what we generally do? We put the soil below this hole and we compare this color with the given color chart. So, accordingly we define which color, what is the number or what is the name of that soil color. So, suppose for example, here this hole is indicating or this color is indicating the soil. So, it will be 5 YR 8 by 4, it is 5 YR is the number and 8 is the subdivision and this is the fourth place. So, it will be 5 YR 8 by 4. So, in this way soil colors are named, and soil colors generally they define the climate, define the parent materials. So, climate, parent materials, degree of weathering, mixture of organic matter, degree of leaching, all those indicates the soil color. Then chemical composition of soil, it may be acidic soil, it may be alkali soil. Then grain size, may be loamy soil, may be sandy soil, may be sandy loamy soil. So, like that. Diagnostic criteria, presence of calcrete, it is important. Last class we are talking something about calcrete and calcrete development and its importance. Then presence of calcrete, root, mottles, clay cottons, these are the diagnostic horizons. So, those soil profiles are distinguished on the basis of this color, basis of chemical composition, basis of grain size, basis of diagnostic criteria. So, by defining a soil horizon, all those parameters, all those characteristics has to be noted by a geologist. Now, the question arises, how the soil forms, what are the factors responsible for formation of the soil. There are 5 key factors, they are responsible for soil formation, and those key factors either which factor will dominate over other, that depends upon the geological condition, the geographical conditions. For example, these 5 factors are parent material, climate, topography, organism and time. So, now you see parent material you cannot change, time you cannot change. So, suppose we take a window of 1 million years, for say 1 million years, within that 1 million years we cannot change the parent material of a place, we cannot change the time. However, we can change these 3, one is topography we can change, because we know there is inversion of topography within geological time scale. There where it is positive topography nowadays, due to weathering and erosion there may be negative topography comes. Similarly, climate, there are many times the climate changes occur in geological past. Organisms, depending upon the change of climate, the organisms also change. Okay. So, that means though there are 5 principal factors or the soil forming processes, out of these 5, this time and parent material, these 2 remain constant, but those 3 factors, that is climate, topography and organisms, they change with time. So, accordingly the characteristics of the soil horizon that will vary. So, under certain conditions, each of these 5 variables can exert the controlling influence. How these different parameters they control the soil forming process, let us discuss. 3 of these factors, that is climate, organism and topography, are likely to change during the process of soil phoresis, but parent material it never changes in the soil forming process. Parent material is a dominant soil forming factor. A parent material, suppose what is the characteristics of the soil? Suppose a soil is developing on granite, a soil is developing on limestone. The characteristics of this soil and that soil will be different. So, that is why the parent material on which the soil is getting developed, that also define which type of color a soil will be, what type of mineral content will be there in the soil horizon, what type of organic matter will be in the soil horizon, what is the color of the soil horizon. So, that depends upon the parent materials. A residual soil cannot contain minerals that are not present in or cannot be made by weathering of this parent material. So, if you see here this photograph, sandstone it is getting some soil, limestone into soil, basalt soil, granite soil. You see all these five photographs of the soil, they are showing different color. Similarly, if we analyze their soil horizon characteristics, that will also vary from one place to another place. So, that is why parent material plays an important role to define the soil characteristics. A residual soil, suppose a residual soil is there. Residual soil means after the development or after this removal of this unnecessary material, a soil horizon will be there. This is called residual soil. That is in situ soil. Not there are two types of soil. One is called in situ soil, another is called transported soil. So, residual soils, they are in situ soil. That is indicating the parent material on which the soil is developed. For example, here if you see this photograph, this is limestone. On the limestone, we are getting thick soil profile development, and within that soil there are horizons, there are sub horizons like that. So, this soil is called residual soil, because it is developed in situ by removal of this unstable minerals and enriching the stable minerals, and that is developed on the developed on this limestone. So, those soil that will hold the characteristics of this limestone. So, this is residual soil. So, residual soil, suppose for example, in a Paleozoic limestone is composed of 90% calcium carbonate, 7% quartz, 3% detrital clay. When weathering of this solution of 5 meters limestone produce a soil profile having 70% sand, 30% clay and hydrated iron oxide. So, that means I want to say a residual soil will hold this characteristics of the parent material, but may not of same composition, because here leaching is involved, removal is involved. So, some unstable minerals will be totally removed, some stable minerals will be enriched. So, the residual soil may not get the exact composition of this parent material. So, I think we should stop here. We will meet in the next class. Thank you very much. Thank you.